Well, hello, everybody. Welcome to Lidar CANEX 2024. I'm your host, Jonathan Murphy. We're privileged today to be working with Natural Resources Canada. They're sharing the update to one of the most fundamental things in geomatics, the system that we use for spatial reference. I'd like to introduce Catherine to everybody. She's in charge of the update. Maybe Catherine, did you want to start by telling us a little bit about yourself and your role with NRCan?
Sure. So, so I'm a section chief, currently acting director at the Natural Resources Canada Canadian Geodetic Survey. So, we're the organization that, as John mentioned, defines these geodetic reference systems. In particular, I have been leading a group of provincial partners in the deployment of this system across various jurisdictions. Other people in my division are doing the work towards defining the new system. So it's sort of a team effort. And my role has been on the implementation side, working with our American partners and with our provincial partners.
Excellent, thank you. So everybody, there's a Q&A system in your Zoom. So if you have questions, feel free to post them. We're going to address questions at the end when I'm going to come back on screen, and it's going to be live Q&A. I believe we're going to be here for your presentation, Catherine. It's about an hour, I think.
I think my presentation is about 45 minutes, and then there's time for questions at the end of it.
Okay, perfect. All right. Well, I will see you on the other side. You can go ahead and share your screen.
Okay, thanks, John. Here we go. I'm hoping everybody can see my screen here. If not, let me know. But so I wanted to say thank you to John for helping host this event. This is a subject that we've been talking to a number of people about in different communities. And as we're trying to broaden our reach on this topic to communities that aren't maybe our regular points of contact in general, it's been really helpful to have John and GoGeomatics support hosting this event and increasing that reach a little bit. I would like to also note that I have two colleagues on the line with me in a sort of a mini panel, and that's Brian Donahue, who leads our client services team and also leads the provincial federal coordination group on this topic. And then I also have Jean-Sébastien Moreau, who's from our mapping and Earth observation group. He works on the high resolution DEM products, and in that role he does quite a lot of work with LiDAR data, including dealing with geodetic referencing questions around that. So thank you both for helping me with the presentation and also for being here today to answer questions at the end if needed. Okay, so I think we've had enough of an introduction on what this is. I'll just start right in. And this is what I would like to talk to you about today. So I have three parts and then a little summary at the end. So I'm going to start by talking about what this modernization is, a bit of background on why we're doing this, what exactly is it from both our side and the American side. And I want to highlight the rationale for making this change. It's not something that happens easily or quickly. And so there has to be a strong motivation to do that. The second part is going to be talking about some of the work we're doing with our provincial partners to make sure that these frames, to take the opportunity to unify the reference frame adoption across the country. So we'll talk a little bit about that. And then the last section, I'll be highlighting some ideas on what it's going to be like to work in this modernized system and this new system. And that's from our point of view, but I'm hopeful that, with ongoing conversations here, we'll start to get a better sense of what this means for all the communities that will be affected. And then at the end, I'll summarize and I'll open the floor to questions. So part one. So the plan is both Canada and the US will modernize our spatial reference systems in 2025. This is been a long time coming. We've been talking about this for 15 or more years. Our partners in the US are the National Geodetic Survey. They're our equivalent, Canadian Geodetic Survey equivalent. And this is an ongoing project that's been going for quite some time now. There's a lot of documentation available, and the presentation will have links to some of that at the end there. I'm going to start with a little background, though. So what exactly is a spatial reference system? So as you are likely aware, everything you position is relative to something. And for geospatial data, it's relative to a geodetic reference system. So that's affects surveying, mapping, geosciences. We use those systems. The systems components include what are the axes that we're referring ourselves to. So it's the origin, orientation, and scale of those axes. What is the shape of the ellipsoid that we want to refer ourselves to? So we're not, referencing to the center of the Earth there. And then systems also contain elements of physical parameters. For instance, what's the motion of the tectonic plate? What's the definition of mean sea level for heights? So this is all components of the systems. And these systems don't change very often. In fact, it's on a 50 to 100-year timescale that we change these things. So it's a major change. And this graph, I'm trying to highlight a couple of things. The first thing is the evolution of the systems that you can see here. So I'll maybe focus on the heights one. We defined a Canadian Vertical Datum of 1928, which some of you might recognize as the height system back in the 20s. And that was based on technology that is evolved quite a lot since then. So it was based on a definition of mean sea level in Pointe-au-Père, Quebec, and then leveled across the country, which locally worked quite well, but over the country had some biases and distortions. So about 100 years later, almost 100 years later, we redefined this with a more North American definition of mean sea level and a technology that enabled us to map it out over the whole country based on gravity observations. And allowed us to access it through GPS surveys. So this is the kind of evolution that happens. You have a system, you get new technologies, and here I'm showing the evolution of the technologies. They both identify problems with the system and allow you to access the system more accurately. On the geometric side, we had NAD 27, introduced NAD 83, in the 80s and 90s, and now it's 50 years later, and it's time to update that as well. On the axis here, I'm showing that the goal is to always have the system more accurate than the technologies that are accessing the system. So those are the main messages in this diagram here. So they happen every 50 to 100 years. Reference frames, however, that is the physical realization of the system. And by that, we mean we assign coordinates to markers in the ground. Here I'm showing a couple of different networks here. It's their active control networks, so networks that have, equipment on them all the time, and we can update their coordinates quite regularly. So there's the Canadian one, that's the NRCan system, and then also the private one. So the realization of the frame is the definition of coordinates on these kinds of networks and others as well. So these are updated a lot more often. We get a new station comes in, we have to include it, new models for the definition of those, the calculation of those coordinates, new techniques are used, et cetera, et cetera. So these are updated quite a bit more often. An example of one of those is NAD 83 CSRS version 7. I'm going to highlight here and again later. So it's very important to maintain accurate metadata indicating the reference frames for all coordinates in geospatial files. So as these things keep changing, we need to make sure that the observations you've made have that metadata attached to it. Modern reference frames take into account that the Earth is a dynamic planet. So as we're looking for more accuracy, the changes that are happening on the ground due to physical processes are being taken into account in the modern reference frame. So there's different kinds of changes that occur, dramatic events like earthquakes, and here I'm showing a map from our earthquake, NRCan's earthquake website there, landslides, and these things are unpredictable and have an impact. And once that happens, the coordinates are going to change. And then there's predictable motions. And here I'm showing like tectonic motions on the West Coast or seasonal changes, and also glacial isostatic adjustment, which I'm highlighting here. Here's the evolution of the ice sheet from 18 to 14,000 years ago. And as this ice sheet unloaded, the ground has uplifted in some places and is sinking in others. And that's a motion that we can model and predict. And so all of these things we can take into account in modern reference frames because we have the technology to analyze things at that level of detail. So what's important at that part about that is that they are dynamic, but they are adopted at a specific epoch, and you're able to change the epoch of your data. So an example of that is NAT83 CSRS version 7 as before, but it's adopted at the official epoch of 2010. So I'm expanding this little note here, which is maintaining accurate metadata is essential, include indicating reference frames and epochs for all coordinates and geospatial files. So what's happening exactly in 2025? Now that we have that background, for the geometric side, it's an entirely new system. So we're replacing NAT83 with the North American Terrestrial Reference Frame of 2022, or NatRef 2022, and both countries are doing this at the same time. We're on target to do this by the end of 2025 at this time. And it's a whole new system with its own series of realizations coming afterwards. For the height side, so heights above mean sea level, we are not going to a whole new system. We are in Canada just adopting a new realization of the system. So it's a new frame. So in the US and Mexico, they are still operating on NAVD88, which is a leveling based frame, which is, like we had for CGVD 28. And they're replacing it with the North American Pacific Geopotential Datum of 2022, NAPGD 2022, which is moving to a more modern system, which is based on gravity and gravity models or geoid models. We are already there with CGVD 2013. And so all we need is a new frame. Another important fact is that they will be using the same definition for mean sea level that we have used in CGVD 2013. And that's a definition that we agreed on in 2012 when we updated this system. So in fact, we're just updating with a new model representing mean sea level. They're updating the whole system. And the model that's going to be representing mean sea level in both countries is exactly the same. We're going to have a common model. So a new system on the geometric side and a new frame on the height side for us. So what's the rationale for making this change right now? And we're going to start with NatRef 2022, the geometric frame. And it's going to be a story a lot about consistency of standards, consistency of data interoperability. So the issue with NAT83 that we found out once GPS started being able to observe, small differences is that it's not geocentric. It's off the geocenter by about 2 meters. GNSS itself and the international reference frame and the WGS84, those are geocentric. So we're not quite consistent with the international standards there. So once we move to NatRef 2022, we will be, and that will better support precise positioning from space, like GNSS. And importantly, it's going to be important for mass market applications. So you can imagine when cell phone apps like that are going to be kind of relied on and integrating data from many different sources. It's going to be important that all those sources are consistently referenced to, common or compatible geodetic reference systems. Another rationale for modernization of our geometric system right now is that we're going to be an improved plate fix system. So the North American plate rotates relative to the international terrestrial reference frame, and I'm showing that here. These are the coordinates at our ACS stations across North America, ours and the American ones, and you can see that relative to the international frame, the whole continent is moving. That means that if we just use the international frame, your coordinates would be moving at a rate of about 2 centimeters per year. So NAT83 and NatRef 2022 are systems that are fixed to the plate to remove that 2 centimeter per year motion from your coordinates on the ground. We can describe that through a set of rotation parameters, which we're working on to define right now. The improvement is going to happen with NatRef in that the rotation parameters that we defined NAT83 with weren't quite right. Again, it turns out afterwards, with the greater accuracy of observations, we we noticed that we over-rotated a little bit. So here's what the plate fixed system of NAT 83 looks like, leaving a little bit of a residual plate motion, and that will disappear in NatRef 2022. It will be an improved dynamic reference frame. So dynamic reference frame, as I alluded to earlier, take into account changes in coordinates due to crustal or local motions, and this is because we're looking for more and more accuracy. We adopt a reference epoch so that everybody can compare apples to apples and have their observations at the same time frame in that changing landscape. It also allows you to change your coordinates to any epoch of your choice. So we do that by looking at the motions that we observe. And here I'm showing one up on the right here, which is a time series at an active control station. And you can see there's a lot of different movement going on here. You can see an annual or semi-annual signal. You can see that the velocities can change as fit to this time series. So we make an estimate of the velocity at these stations, and then we use that to develop, but this is only available at those stations. But so in order to understand the motion affecting your coordinates all over the country, we use that to develop a national crustal motion model. And this is an example of the one that goes with the currently adopted NAT 83 CSRS version 7. What's going to be different in NatRef 2022 is that we're making that they will also have a velocity model of this type for doing similar epoch changes, and we're going to be working very closely with them to make sure that all of the stations that we use here, which are marked with dots, we're using the as close as possible functions describing the motions of those stations. So there's a lot of coordination working with them on that. And right now, it's just a velocity here. And after 2025, we might be able to, we're going to start to look at creating more complex motions. As you can imagine, after an earthquake, it doesn't look like a straight line very much. And maybe there's tools that we can use after 2025 to bring the more complex motions into those estimates of coordinate changes. So this is sort of a summary, but overall, another rationale for us is to really stay consistent with North American standards. So we've been on the same systems, geometric system with the US for 100 years, and we want to continue to be compatible at the Canada-US border. Here we're showing a sort of exaggerated situation where our maybe at the border you would have different offsets there. It's exaggerated in the sense that in reality you would catch that. But if you're an app and you're not making you're pulling in data from different places and you're not making the right transformations, this could be really how it looks. So we've collaborated for over a century, and we have a almost 9,000 kilometer border. And so it's important for us to be consistent with what the US is doing. On the vertical size, this is still a story about consistency with North American standards. So as explained earlier, NAP-GD 2022, or the new height system in the US, is evolving to be a gravity-based datum realized by a geoid model. So because the geoid is tied to the ellipsoid, you can access that everywhere via GPS or GNSS. We made that move about 10 years ago now. So our current system is CGVD 2013. And it's realized by a geoid model called CGG 2013A. So NAP-GD 2022 will use the exact same definition of mean sea level as agreed upon in 2012, and it will use the exact same geoid model. So we are currently working on this model, and CGVD 2013 will use the model, and NAP-GD 2013 will also use the model. The two systems will be exactly the same, and in some sense, NAP-GD 22 is going to be equal, but joining what we are currently having right now. So just in summary, we've been doing all this modernization in steps. So we started building a dynamic reference frame in 2006. We introduced geoid-based vertical datum in 2013, and they're doing it all in one step, which means we've been a little bit out of sync. And also it means they have a lot coming out in 2025, but for us, because it's a slow progression, a lot of the elements are going to feel pretty similar to the users who are already using a lot of these tools. Continue with the story of consistency with North American standards. We get a lot of questions from clients on doing conversions in different situations, and a number of the situations that Brian has recently shared with me relates to the fact that the height systems in Canada and the US are currently at the federally adopted height systems quite different, and there's a lot of situations where we have to do some complex maneuvering to compare the data or to use the data. For instance, in border towns, they have a data set that's coming, or near the border data set that's coming from the US that they want to integrate into their own work. And that one is in their old leveling based height system, NAVD88, and we want to convert it to CGVD 2013. Now, we do offer the tool to be able to do that. So this is our program GPS-H, the desktop version. Some of you are probably familiar with the one. So the way to convert it is you need to download a conversion file, and the conversion file is approximate, right? It's the NAVD88 is a leveling based system. They have a hybrid model that maps that out on a larger scale in the US, which we have access to. So you can go to get that, you download it, you download the desktop app, you upload the model in the desktop app because it's not a Canadian model, so it's not there by default. And then you can do a transformation there. Another example that we're looked at is over the Great Lakes, which obviously have half in NAVD88 and have half in CGVD 2013. And some of the water level surfaces that people are asking for, they're asking for it in one or the other, or both. So you can also do that in the desktop version of GPS-H, or the online version, which we've recently updated so we can handle larger data sets, but it only works on points. You can't do this on a large raster or any other kind of format. So that's a limitation there. And then another example was at the Alaska-Yukon border, where someone is doing some RTK work at the boundary, and they use PPP, our CSRS PPP tool, which some of you are probably familiar with as well, but they want to make this in NAVD88 for their US clients. So we don't provide that in CSRS PP, and it becomes a two-step process. You process your data, and then you have to go to GPS-H or VDatum, which is the American equivalent, in order to fully process all of that. I should note that the differences between NAVD88 and CGVD 2013 are from 20 to 140 centimeters, so the differences are significant. And then the last note is that the only way to really do this accurately is to do a GNSS occupation on a benchmark that has published NAVD88 sites, and that's all the other approaches are going to be a bit more approximate. So kind of in summary, the rationale for modernizing the CSRS at this time is that we're going to get better improved frames for a couple of reasons that I outlined there. And I will see more about that in the last section. We're going to be more consistent with international standards. We're going to be more consistent with North American standards. Another important point related to that is that a lot of the work that people on this call likely are going to need to do if they want to modernize relies on commercial software packages. And the commercial software packages are going to be focused heavily on their biggest market, which is the US. And so being able to change this at the same time means that we can take advantage of those changes, and we can also impact or influence what those changes are, and we are doing that. The last rationale is that this change in 2025 provides an opportunity to unify the reference system usage and adoption across the country. And that is what I'm going to be talking about in the next section. So here we go, unifying reference frames. So geodetic services are a shared responsibility in Canada. So at the federal level, we have the role of defining the reference systems. That's a federal mandate, and that's us at Canadian Geodetic Survey. But provinces have the authority to regulate reference system usage in their jurisdictions, and they also provide control network coordinates. To illustrate that a bit, I've put this figure on the right, which is the hierarchy of networks realizing the frames. And it's an inverted triangle. So at the very foundation of it is an international geodetic observing system, which is very sparse. There's not too many of those, maybe 20 around the planet. And that's the foundation. And then we gradually build layers of networks on top of that. National CACS is the one that I showed you earlier, the Canadian Active Control System, and some of our regional stations, and those are used to define the internet, are defined in the definition of the international reference frame. And then regional, provincial, and commercial active control stations are there's more of them. And then eventually we get to the provincial densification networks, the passive control networks. So I think an important point is we're getting less sort of accurate as we go along, as we go up the triangle, but also we're getting a lot denser. And for people who are doing projects and surveys and they need a geodetic control, it's important for all of these layers to be in a consistent frame. And so that's the goal of this the unification work. We do this, we deliver the reference frame in coordination with the provinces and some other organizations through the Canadian Geodetic Reference System Committee. And Brian is the chair of that, which is a subcommittee of the Canadian Council on Geomatics. And that's their little logo there. So this is just a visual so of what we just talked about. At the federal level, the frames are defined very sparsely, and this is on our active control system. We also have some passive markers that we define the coordinates for, but not very densely, whereas at the provincial network, at the provincial level, they supplement that with the realization of coordinates on this much denser network. This is a snapshot I took from the Ontario Cosine Service showing Ottawa, and you can see there's quite a lot of geodetic control in this area. Every time we update these coordinates requires a pretty significant amount of effort and also a level of expertise on being able to do it. And we have tracked the availability of expertise in all these jurisdictions, and there's definitely been a decline over the years. Back when we did all these long, leveling and other high density field campaigns, there was a lot more people on staff to do this kind of work, and that has definitely reduced across all jurisdictions. And what that means is that different NAT 83 versions are adopted in use in Canada. As we've rolled them out federally, not all the provinces have been able to keep up or felt that there was a strong need to do it. So this is the picture I'm showing on the right. These are the different versions of NAT 83 or different realizations of that frame adopted in Canada across the country right now. We've got everything from version 2, 1997 to version 7, 2010. And the differences between these versions are on the order of a decimeter or more. But when we have some of these groups moving to NatRef, the differences are going to be much greater, on the order of 1 to 2 meters, and we're going to see that a little bit later. And this is at the provincial level. But if we look at the municipal level, it's even more complex. We have some jurisdictions still using the legacy datums, such as NAD 27 being used in Toronto. Many people have created their own local little reference networks. So this is at a high level already complex, and if you dig into it, it's even more complex. On the height side, it's a similar story. So we have two height systems currently formally adopted by the provinces in Canada. So CGVD 28, the leveling-based system, and CGVD 2013. On this plot here, I've shown in blue the jurisdictions that have officially adopted CGVD 2013, and in orange, the jurisdictions that are still officially in CGVD 28. And on top of that, we have plotted the PPP results that have come through our system, our tool. So there are 216,000 submissions to PPP from 2022. And when you submit your file to be processed by PPP, you get to select the height system that you want your results in. So those who selected CGVD 28 are orange dots. Those who selected CGVD 2013 are blue dots. And interestingly, we find that in the provinces that have formally adopted CGVD 2013, the usage of those through our PPP service are much increased relative to the other ones. So the message we took from this is that really provincial adoption really does matter in the usage of these systems. I'm going to give an example of motivation for moving, additional motivation for moving to that system. So this is an example of working in the Greater Toronto Area. As we noted, that's still in NAD 27, and they're officially still on CGVD 28. And I recently spoke to someone working on some projects in the city, and he gave me a list of all the different reference frames he was trying to deal with through a combination of our tools and more than 2 different GIS tools. And so he's working on NAD 27, 2 different realizations of it. NAD 83, a very early edition, which was only 2D and turned out to be fairly distorted. NAD, all the different versions of NAD 83 CSRS. And in the height system, as well, some the CGVD 28 different realization of it. So, you know, there's local datums, there's some data coming into WGS 84. There's also map projections that he has to deal with. So he's integrating all of these different data sources from different systems, and not all of the software that he uses has the tools to do that. So he's spending quite a lot of time building software libraries, customizing workflows, trying to figure out to make sure these things are all lined up properly to be able to perform his projects. Sometimes these massive operations, you know, crash software or don't transform correctly, so there's a lot of double checking involved, and often errors come up, or he you know, identifies that there's been an error somewhere, and the lines aren't matching exactly, and it's quite a significant effort to track where that occurred and how to fix it, and this can take, you know, months, and it's quite an expensive operation to keep on top of all these different systems being used in his project. So we've been trying to collect some of these stories to try to understand, you know, what is the motivation for people to move. And I think the motivation is really, we need to get to a place where we can be more efficient, and we can, you know, not have to do all of this customization, catching blunders, you know, going back to fix things. And just the effort to make sure that the coordination is being done properly. So CGRSC members are on board to work towards this. So that's the provinces and some other jurisdictions and some other federal groups as well. And to that end, they've developed a multi-element modernization roadmap. And specifically, and we've been working on that since about 2018, discussions and looking at what it means and what is going to be needed. And as of last year, the provincial members agreed that 2030 is an achievable target. So if we go federally in 2025, they feel that by 2030, they can modernize all to the new system. That involves updating their coordinates, making any necessary changes to the networks, both the passive and the active, and also looking at things like where is the usage of these systems encoded, and how do we change up the regulations that that require the usage of these. So they have actively been working on this, and their goal is 2030. We are now entering kind of a phase 2 on the communication side. We've been communicating to you know, mostly surveying, engineering kind of audience at this time, but we're starting to think quite a lot more on what are the considerations for geospatial data sets. What tools you need, what products do you need, you know, what kind of support is going to be required, or documentation. So the focus on that right now is stakeholder outreach and communication, and this is part of it. This presentation today. Again, looking at what tools or products, including for moving data from legacy datums, and ensuring that the GIS tools are available to migrate to and work in dynamic datums. And we'll come back to that a little bit later as well. So we're on to part 3 now, which is working in the modernized system. So I'm going to start with what the difference is going to look like. So NatRef 2022 is going to be aligned with the International Terrestrial System in 2020. So that means that we are going to be moving back to the International Terrestrial Reference Frame. It will be adopted at Epoch 2020. So that means that in ITRF and NatRef 2022 will be exactly identical at Epoch 2020. That will be different from NAT83 by about 1 to 2 meters. And I am showing here a plot of the differences between NatRef 2022 versus NAT83 in the vertical, the expected differences. Again, this is still preliminary data we have for NatRef 2022, and it's going to be on the order of 0.4 to 1.4 meter difference. You can see it grades largely because of the shift in the center of the Earth there. All the transformations between the various versions of NAT83 and NatRef 2022 will be available through our website or through the ISO Geodetic Registry and EPSG. After 2020, we're going to be rotating away from the International Terrestrial Reference Frame using the rotation parameters that we're currently defining to capture the motion of the North American plate. So we're going to be separating from ITRF 2020, and I'm reiterating again that it's going to be important in NatRef 2022 to also keep your metadata up to date. You're going to be, the epoch is going to be important there, and it's important to keep those data sets well labeled. So as I mentioned before, we're going to be having an improved version of the model that will map the dynamic portion of the reference frame. The models themselves will evolve in complexity after 2025, enabled by some new international standards, which I'll talk a little bit more about later. And these standards are being developed by this international group, but the Canada and the US have agreed to adopt these new standards. So all the new products we have, including things like this crustal velocity model, are going to be released in these new standards. What is it going to look like on the CGVD 2013 or the height side? So we're going to be updating it with a new geoid model, which is going to be a common model with the US, so the same model. So basically we're going from CGVD 2013 realized by this Canadian model to CGVD 2013 realized by a shared model with the US called Geoid 2022, and they're just working on this now. It should be coming out this year. The difference will be small. Here I've shown a plot of approximate difference that we're expecting from the current realization of CGVD 2013 and the upcoming one based on a test version of this model. You can see the main feature is these stripes, and these stripes were a result of the processing of the satellite gravity data that was used in 2013, and those have been removed. There's going to be some small differences in other areas as well due to different data that has been incorporated this time. And we're using a common data set with the US, so that'll improve some areas as well. But we're looking at less than 10 centimeters. And when you have your orthometric heights, that will be the sort of difference that you're going to see. I am also noting here that if you're moving from CGVD 28 to CGVD 2013, either now or in the new realization of it, the difference is going to be a lot bigger. What is it going to look like as a user of CGS tools? Pretty similar. So we will continue to provide coordinates and velocities for our active control stations. We'll have coordinates for some passive control stations. The tools will look the same. The main difference is that the default settings is going to be NatRef 2022, Epoch 2020, or the new geoid model. So functionally, it'll be the same. We will continue to support NAT83 for some time in the future, but the systems will remain very familiar feeling for accessing those coordinates. As I mentioned earlier, one of our most used tools is the CSRS precise point positioning service. This is used a lot, especially in remote areas where passive control is not maintained. And then surveyors, which allows surveyors to set their own survey control. This is the same data set that I showed in the heights figure earlier, but it shows a bit better the usage of these of this service in Canada. We processed again 216,000 files in 2022 from 3,500 different users, and globally we're processing on the order of 1.5 million, 1.4 million a year. So it's quite an extensively used tool. This will include, after 2025 or at the end of 2025, it will include support for NatRef 2022 and the new realization of CGVD 2013. Again, everything else will remain more or less the same. It's just going to be, you'll have the option to use that. Other improvements we're looking at is right now it supports GPS and GLONASS, and we're looking at including support for Galileo in that service. We also provide some transformation tools, which may sound familiar. TREC, the transformation tool in GPSH, which I mentioned earlier, will still be available either as a web application, or you can download it, install it on your PC, or through use it through our CSRS API. Similarly, it'll support NatRef 2022, the new realization of CGVD 2013, and the new National Crustal Velocity Model. The defaults will be for those new systems, but we'll continue to support the old ones for some time. I noted here that we've recently upgraded the ability of GPSH to process larger data sets, which might be useful to some people in this meeting. Oops. There. Another thing that we are talking about with our provincial partners quite a lot more recently is the ability to move data from legacy datums, NAD 27, NAD 83, original CGVD 2013, to modern ones. In order to facilitate migration, we need to the modern system, we need to have some tools available. These do not have mathematical transformations because they're distorted due to the technology that was used to define them originally. But we have developed some distortion models which allows people to move from, say, NAD 27 to NAD 83. So I'm showing that here. If you go from NAD 27 to NAD 83 original, you're going to need to use a distortion model or a grid shift model, we call them. And nationally, we have a model that allows you to do that over the whole country. An early realization, NAD 83, NAD 83 original, was also found to be distorted, and we redefined it as NAD 83 CSRS, and the provinces provided the grid shift files for this transformation. And if you go into our website, you'll see that there's a whole list of grid shift files available for different provinces, but not all provinces. So that's why I've marked it in red. For instance, Manitoba and the territories do not have a grid shift file that allows you to go from NAD 83 original to NAD 83 CSRS. And then the final step would be to go to NatRef 2022. This is purely a mathematical transformation and the application of the velocity model for epoch changes. So what we've been telling people is that the last version of NAD 83 that will come out will be sort of like an alpha product for NatRef 2022. If people can get themselves to here from a legacy datum, the change to there is going to be relatively simple. It's it's sort of a step to be made that some people are making right now to move to the modern current system, anticipating that the move to NatRef 2022 will be a small step from there. Some jurisdictions are looking at, do they need to create another grid shift file? Do they have new observations that they can include? What are the tools that are going to be needed to do that? Is there a user need? Depends on a lot on this geospatial community. I'm noting again that many jurisdictions and different projects are using local datums, which is outside of this, but is a consideration in places where there is no grid shift file to get you all the way across that update. And then I also was noting that to go from CGVD 28 to CGVD 2013, we have a height transformation model, which maps CGVD 2013 using a geoid model between the leveling lines, and you can do a difference between CGVD 2013 and CGVD 28 across the country. And so that move from the legacy datum is a bit simpler. Another thing that we've talked about quite a lot is what are going to be the requirements for people to move large and numerous geospatial data layers. Cadastral parcels, LiDAR data sets, road networks, there's a lot of them out there and some of them are big. So the things that will be needed are the ability to do this kind of work in dynamic datums, which means we have the mathematical transformation, and then we have the epoch changes using deformation models, such as NAT83 version 7 velocity model, and that is not currently available in some of the popular GIS software. We also need the ability to use distortion models to move from legacy datums where there are no mathematical transformations, and I'm repeating that again, but the grid shift files, to apply grid shift files, and the conversion grid from CGV 28 to 2013. The last thing that we've spent some time on is developing this new set of OGC standards. So there's two of them, the Graded Geodetic Data Exchange Format, GGXF, and the Deformation Model Functional Model. And these are new geodetic grid standard, which will enable a more efficient use and exchange of regularly gridded data, such as the geoid model or the velocity model, and will be adopted by different software developers, everywhere. So it would be easier for commercial software to implement new grids if these new grids are all coming at them in the same format. Some of the vendors, Esri in particular, have been involved in the definition of these standards through the OGC, the Open Geospatial Consortium groups. And importantly, Canada and the US have formally agreed to use these new standards for the release of new products, which will provide an impetus to the uptake of those new standards. We held a summit over a year ago now, almost a year and a half ago now, to talk to the geospatial software developers about what's coming, what does it mean, what are these new standards, what tools are going to be needed, or what functionalities are likely to be needed by for people working in dynamic datums. We had, if you get this presentation, we have all the presentations linked here. Excuse me. We had several geospatial software developers there, and 3 presented on day 2 of the event. So that included Esri, Trimble, and Proj, which is the open source software. And they all indicated that they would be ready by 2025 to support these systems if test products are made available by our American partners and ourselves. So we have been working with our US partners to develop a phased rollout plan of geoid model alpha version, geo model beta version, and we're working towards supplying these to the software developers. In fact, Trimble and Project are already have that functionality and are already using the NAT83 velocity grid. Esri is building the functionality, but he flagged that it might not be available in all the product lines initially. So they're actively developing that though. And we've talked to some NRCan partners here who are users of GIS software about their modernization plans after 2025 and starting to look at these tools and maybe support the kind of feedback that the developers are going to be getting once people start using them. On the Proj side, the NRCan's Center for Mapping and Earth Observation, CCMEO, is also supporting the development of improved ways of using transformation tools commonly used in LiDAR data sets. So specifically, they're working with Proj to develop streamlined processes for epoch and datum transformations using the velocity model, so for dynamic datums. And just in the last week, it has become possible to use Proj 9.4 in GDAL and PDAL to transform rasters and point cloud data using the velocity model, so epoch transformations. They're working on tutorials and some documentation that will be released soon, but you can already look at some of what's happening there on GitHub. And that's come to the end of what I wanted to say. I'll just summarize it. Just a take-home message here is by mid to late 2025, NatRef and a new realization of CGD 2013 will be adopted federally. That date still seems accurate. Provincial agencies are targeting moving their own networks and geodetic products to 2030 in 2030. We're both working together to facilitate the migration of geospatial data, and it's very important to us to have feedback from that community. And the goal is consistency. I tried to repeat this word a few times, internationally in North America and across all Canadian jurisdictions. This is definitely not going to be an overnight process. There will be some effort required there from everyone who wants to do it. But eventually, if all these things become consistent, there's going to be a lot of efficiencies found, which we're hoping that motivates people to put the effort in now to reach that goal. Next steps for us. So we'll continue to work closely with our partners in the US to define the new systems and to coordinate their implementation. So when are they going to get released? How are we going to be doing the versioning? These are all kind of the discussions we're having right now. We'll continue to work with software developers to ensure the tools are ready after 2025. The CGRC members are making detailed plans now. So we've moved from what should we do sort of high level to what software we're going to use, what kind of field work is going to be required, what kind of funding are we going to require to do this migration, still targeting 2030. We hope to have another summit this fall, this time targeting software developers as well as GNSS equipment manufacturers and potentially service providers as well. So more to come on that. And then we use the opportunity of John hosting us at GoGeomatics here to provide a high-level overview on, to people from across the country. But we plan to hold some more focused discussions with different geospatial groups in the coming year. So municipalities or different government departments working in different types of data layers. So you may hear from one or more of us as we follow up on this presentation. I've listed some other resources if you'd like to learn more about this. They're linked in the presentation, and we'll make sure you get the presentation document. And that's it. If we have questions, I'm happy to take some.
Thank you, Catherine. That was fantastic. I see that we've got quite a few questions in the Q&A. So the first one is from an anonymous attendee asking, what would the effect be using worst case scenario if GNSS went offline?
Well, I don't know. Globally, what the effect would be, you'd have to remember all your old techniques. Not sure how ready people are to do that. So I don't know how to really answer that question. There will still be references. I will say that our provinces are still supporting passive control. So there are reference markers available if you need to go back to that. We're doing that less and less at the national level, but definitely a focus of the provincial migration is updating and even in some case expanding their high precision passive control networks for access in that sense.
Thank you. The next question is there going to be the presentation made available after? Yes, it will be emailed out. There's a tongue-in-cheek question. Couldn't we have come up with a more pronounceable acronym? I speak as a teacher.
Well, I have to say, we didn't come up with it. It's the US defining that, and it sort of describes it well, so we went with it.
Great. I think there's a couple of the geomatics programs across the country are actually showing this to classrooms of students. So that's fun. Another question.
And it's hard to see how it will be called. Right now, NAT 83 CSRS is commonly just called CSRS. So we'll see how that evolves once NatRef 2020 comes out.
Great. Could you expand on how this new system will enable handling gravity, micro changes resulting from increasing continental ice sheet melting and or extensive groundwater withdrawals?
So our new height system is gravity-based. That means that we're using terrestrial data, marine data, and satellite data to develop the geoid model that is then applied as a definition of mean sea level across North America. We're defining it as a static system. The geoid changes very slowly, and our input from our partners at the CGRC and in other discussions is that it's such a small change to that height over time that it's not worth, kind of looking at the changes to the geoid height. It's very small. It's within error. People who are really worried about the details of the changes in gravity due to things like GIA or groundwater, for instance, we will be supplying actually a geoid, a dynamic geoid, so a change in geoid model, but it's only going to be available for scientific purposes. It may be in GPSH, so you can see what kind of effect that's having, but it's not officially part of the height system at this time. Yeah, so there may be some, and as we get to more, accuracy requirements in some domains, it could be an important tool. And we are working with the US on developing that dynamic geoid model. So it will be available, just not officially part of the system.
Great. Question here from Bernie. What are the parameters for transforming 2D coordinates from NAD83 to NADRF 2022, and where can I find them?
So we don't have them yet. We're just looking at that. We've recently gotten some information from an academic contract on what those rotation parameters for the plate could be, and there's a few options. So we're testing them right now, and we'll come to a decision with our American partners on what those rotation parameters are. So at this time, NatRef 2022 is not yet fully defined. Once it is, which is late 2025, they'll be available in the ISO Geodetic Registry and EPSG through all of our tools on our website. You'll be able to access those parameters at that time, but we're still defining them right now.
So I think that answers the next question as well from Bernie about, is there a one-step process to transform 3D coordinates from NAD83 to the NATFRF 2022?
Yes, it will be.
Yeah.
You can do it through T-Rex. All of the GIS software will have that ability too.
Cool. Fiona, why would jurisdictions still be using NAD 27? It seems very irresponsible. It's more of an editorial.
I don't work for one of those jurisdictions, so maybe they can answer that. I think because locally it's quite accurate. Locally, the at the scale at which some of the like cities operate, it's actually accurate and it fulfills their needs in that sense. Where I see the real challenge right now is that people are working in all these other systems, and so you're getting data from all sorts of different reference frames, and it's a real requirement to make sure that you're integrating data that's all in the same system. So for me, that's a lot of the motivation. The RTK service providers, they're going to prefer to work in a modern system and not feed you, 2 or 3 different, streams of data in different systems. So I think they're going to, the pressure is coming from that side of things. Yeah. Even CGV 28, which across the country has a bias to it. Locally, it's very accurate.
Right. Question here from Greg. Why is the CGVD 2013 name not changing? Adding a reference to the geoid model in the name seems more complex than needed.
Again, feedback from our provincial and other partners. And also because of that piece that we discussed earlier, the US is formally adopting a dynamic geoid model as part of the reference frame. So in that sense, their system is a little bit different. I think if we eventually adopt that, we may adopt the name NAPGD 2022. Part of the challenge as well is that people are still adopting CGVD 2013, and it's being put in legislation or contract requirements, and keeping that name is just simpler for people at this time. That was the feedback that we got. If you change the name, you have to go back and change all the things that refer to it. So it is possible that we will eventually adopt the name NAPGD 2022, like in 10 years or something like this. But for now, we're sticking to the same name.
Great. There's a question here that isn't prefaced. The question is, what about Field Genius from Microsurvey? I would imagine that that's referencing, were they included in the consultation? Are they getting ready for this as well?
We did invite them to the summit. I can't recall if they attended or not, but we definitely like survey all of the manufacturers and software developers when we have these events and make sure that that invitation goes wide and everybody has the opportunity to come and talk to us about where they're at and what they need.
And shameless plug by me, hopefully a lot of these manufacturers will be at the National Geomatics Expo in Calgary this October, and so will NRCan, so everybody can get together. Another question, fantastic information. Oh, another one about slides. Yes, the slides are going to be available. Question about Leica and others. I think that's already really been answered.
Yeah, we hope to engage with them more in the fall. I think generally they're aware we have a RTK compliance program in which they send us their data and we define their coordinates, and then it's sort of a compliance program that's available online for people to make sure that their coordinates are still compliant with what they're supposed to be. And so through that, we're in quite close contact with all the RTK providers and in related equipment manufacturers as well.
Great. An anonymous question. It's a bit long. Adopting new standards before they are well supported in the industry adds needless risk to such a frame update. I was told in the software vendor adoption meeting last year that NRCan was going to continue to provide their grids and their legacy formats in the short, medium term, as well as such as NT version 2. Has that plan changed?
Plan is to we don't have the new grid formats available to us yet. They're still being voted on by the OGC, and there's some tools that they should be developing that we'll use. The plan is to so there's one more version of NAT 83 coming out, and it's going to come out sometime this year. And all of those products will be in the existing formats, but we may also make them available in the new formats. I get the point about, these new formats take a while to settle in, but they're very similar in many senses to what we're using already. And I'm not sure this is something that we've 100% agreed upon yet with NGS, but I feel that we will be releasing it mainly in the new formats after 2025.
We've got, you mentioned Brian and Jean-Sebastien waiting in the wings in case there's questions that they needed answered. Did you want to bring them forward now?
Sure.
Or
yes, please. Anytime you want to step in, feel free. Do they just need
Brian,
to unmute?
Jean, they just need to unmute and turn on their cameras, and then they'll be visible to everybody.
Yeah, hi.
Oh. Is there anything, Jean-Sebastien, that you wanted to add so far to any of the questions, the responses?
I don't see any questions relating to the work that we have done with Proj yet, but if there are some, we'd be happy to answer.
It's after, hi, Brian. I'm going to read the last question. I see that Esri, Trimble, and Proj are supporting grid shift files and velocities. Is Autodesk being given the same opportunity?
I wouldn't know that. Do you know, Catherine?
I don't know.
The same opportunity to do what? Sorry, I think I missed the start.
Are they supporting grid shift files and velocity models?
I think they're supporting grid shift files, but I don't think they're supporting the velocity model. They were invited to the summit, but I don't recall if they attended or not.
Mm-hmm.
But everyone's welcome to, to get access to all of our models.
Right. There's another question here from Greg. Could you please speak a bit more on the differences between CGVD 2013 realized by CGG 2013A versus Geoid 2022? Will there be a vertical shift in coordinates for a given monument? And if so, how big might the shift be?
So they're still developing the new geoid model that's going to be common for all of North America. But on, I forget which slide, there was an estimate of the differences. So the differences will be across the country. There will be small differences, but they're all going to be less than 10 centimeters. And most of the time, much less than that. There's some places in BC where they have some new elevation data where it's going to be, kind of going up from the 2-3 centimeter mark. But yes, there will be a difference. It will be small of that order. It's not. If you're looking at differences between CGVD 28 and CGVD 2013, that's 50-60 centimeters different in many places. So that's quite a big difference. I don't know, Brian, if you had anything to add to that.
No, I think that covers it. There'll be a model provided that'll can be used to do the conversion between the two as well.
Okay, great. There's another question here from Bill. Is there a plan to merge monument search systems from different provinces? Is merge cosine from Ontario and mascot from BC into a singular website?
I don't recall a lot of discussion around that, Brian, do you?
No, there's currently no plan to do that. I mean, in a perfect world, we would be working on that, or the different jurisdictions would be working on that, but it would require quite a bit of resourcing, which I don't think they have at this time. So I think at this time they're continuing with the status quo. But really, that's more of a question for each individual jurisdiction.
Mm-hmm.
Okay, another question here from the audience, from Andre. Even if the grids and velocity models will be available in the new OGC standards, existing formats like NT version 2 are well supported in the wild. While those new standards are not, will the grids also be available from NRCan with existing well-supported formats such as NT v2?
Our hope is to encourage people to use it. So again, this is not fully defined yet, but our thoughts were to release them in the modern grids, but provide some conversion tools which may be provided by others as well. So that's not something we've fully landed on there, but our hope is to really move to, because it will help, enable the software developers to have a common standard used across the board.
I think we are welcome to feedback on that. I mean, we haven't really made a decision 100% obvious. Like, for sure, the legacy data sets will continue to be available in the legacy formats for some time. We were thinking of putting out the new modernized geodetic grids in the new format to encourage adoption. But if software vendors aren't ready for them, then we're going to provide them in the legacy systems, or provide them with a conversion tool to convert between them, because our number one goal is adoption. And the main reason for these new standard formats is feedback from many of the software developers who were telling us it's too hard for us to quickly implement your geodetic models, like your crustal motion model, because you have a specific format in Canada. Australia has a different format. New Zealand has a different format. So we have to support 50 different, geodetic grid formats internationally, and that's a lot of overhead. So they pushed us to come up with a common standard that'll be used internationally, so they can implement one grid format and then take in the models from all different countries. So that was the impetus for this OGC standard. And I think it will be a big benefit, but obviously there'll be a bit of a implementation curve initially.
people are still using NAD27 because many municipalities have thousands of engineering plans and documents with NAD27 coordinates and heights. And I think that is accurate. It's quite a significant effort to change all that. Wrap your head around how to manage a change in terms of, do you have a go, no go, or do you deal with all that kind of thing? And so I think our role is to provide the tools to make that easier. I will say that when we moved from NAD27 to NAD83, that was probably harder than what it's going to be this time.
Is this transformation going to have an impact on the products like road networks, STRM, the QSTRM boundary files, or when the software adopts NATFRF 2022, the products will shift accordingly? Thank you.
The coordinates will shift, and it'll be a mathematical transformation. So I guess I'm not totally clear on the question. So it's different when you transform it, the coordinates will be different. Everything relatively will be the same.
I could jump in on that one, maybe, Catherine. I think the goal is to have the the software platforms ready to support the new system as well as the transformation between the systems. So if you bring in road network in NatRef 2022 and you have other layers in a different system, it can transform them dynamically on the fly. I think we're adopting the new geodetic reference systems federally in 2025, but then the stakeholders will slowly update their systems and services and products after 2025. So when the national road network or the national DEM get released in these new systems will depend on others' timelines. So I think eventually the plan will be to have these all in the new systems, but hopefully the software will also be in a position to be able to dynamically transform different layers to make all these different layers and different systems interoperable.
Given the speed of tech, coming AI, lack of geodetic expertise, need for geospatial accuracy in more and more industries looking forward, is there a possible future where we gain consistency you seek by moving towards active control at the user level? This could increase consistency, eliminate perpetuation of creation of legacy data. This could maybe help ease change fatigue, parse the users that actually need absolute space accuracies from those that need relative space. Municipalities maintain operations in local or older datums, holds one ACS with which to update local coordinates as needed. Could this also eliminate the need for multiple grid shift files, transformation software, etc.? Is the future active control and sunsetting for passive methodologies?
I'll start that one, but maybe I'll flip it to you after, Brian. I would say we have been letting go of passive control at the federal level for some time now. So for us, active control is definitely our focus at this time. And I think also for municipalities, they're doing more or less what's being said here. And even the provinces, they're looking at what can we do? Do we need to do anything for our active control network to help us update our passive control? And that's the conversations that's happening across several provinces. And some of that is working with private service providers to provide that kind of support. I'm not a surveyor myself, but my feeling is many surveyors and many legislations and many plans and still require a tie to a monument that's inside of the plan. Maybe I'll flip it to you there, Brian.
Yeah, and I think passive control can also play a role in monitoring these active control systems. Maybe just backing up a little bit, one of the struggles is, locally these passive systems are accurate, but people aren't using the classical technologies to access them in all cases anymore. So there's a bit of a challenge in using a classical network, but using a modern positioning technique like GNSS. So people are trying to use real-time, high-precision GNSS techniques, but then trying to work it into a sort of a classical passive control network. And it doesn't always fit without doing, distorting the positions and transforming them and doing a bunch of things on the fly. So that's kind of the challenge. And that's where we see one of the big benefits of modernizing is you can take advantage of these modernized services and systems and all these, new emerging applications that come along with that. But if you're, still working in the classical, say, NAD27, then you have to ensure that, when you're positioning from space, that you're distorting those positions to make it fit into your sort of classical system. And that's a big challenge. I think passive control will continue to play a role, but I think that role will diminish over time.
Another question for Bernie. Which new OGC format is the replacement for NT version 2 binary grid shift file GSB?
That will be the GGXF, and it's fairly similar, the structure of the GGXF and the NTV2, if I've understood it correctly. So it's a regular grid with the possibility of doing sub-grids at a denser level. And they've defined all the metadata that goes with that, and they're just looking at that now.
One thing maybe to mention about the GGXF, it's more of a generalized grid format, so it can support all the existing formats. So it's going to be, this new OGC standard will support NTV2 format. It'll support our 3D velocity model grid format. It'll support our current geoid model format, BYN. It'll support the US geoid model format, BIN. So the idea is to have one standard format that will support all types of geodetic grids.
In Nova Scotia, we have adopted NAD83 and CGVD 2013. We have used a generic vertical datum name of CGVD 2013. Continued use of the generic CGVD 2013 will become ambiguous. Okay.
That we are still working on is a standard versioning for both the new modernized systems. So in the height system, we haven't completely developed the versioning system we're going to be going with in the future, but it could be something like, it'll be CGVD 2013, but there could be a version 1, a version 2, a version 3, similar to what we've had in the past with NAD83 CSRS.
And especially, I think, in Nova Scotia, where things are relatively flat, the difference between the realizations will be small inside of the error budget for the model itself.
Yeah, it's small, and it's the small changes are also smooth. So in regions, there might be a 2 centimeter change, but it'll be smooth across the region. But one of our main impetus for updating the realization, well, there's 2 main ones, as Catherine mentioned in the presentation. We want to remove that striping effect from the satellite gravity data. And we also want to have a consistent height system across the Canada-US border. So although the changes aren't too big between CGG 2013A and Geoid 2022, it's important for consistency across the Canada-US border, especially for applications like water management and flood mapping and things like that, where you really need that consistent height system.
Proj is supporting geodetic TIFF grids for years, essentially a geotiff. Are you considering using it also?
Maybe that's a question for Jean-Sébastien, or is that a question for us? We already release our products in GeoTIFF.
I guess the question is, will you continue to support this format when the new system is adopted, or with the new format coming from OGC?
It's not clear to me either.
It's referring to the new OGC standard, which is not using GeoTIFF. It's binary format. But I think there is still some discussions ongoing, and that's really hasn't been decided yet, I don't think.
Mm-hmm.
Maybe I guess that Proj will support both of them, so we'll still support the TIFF format and also the new standard. But I'm guessing here. Was that the idea, Catherine?
Well, I don't think we know that from Proj. They prefer GeoTIFF, and the new standard is NetCDF. So I think there's still some discussions to be had around that. The new standard is being defined now, but they have signaled that they're open to having both of those binary formats included, and that they were accepting comments on that. Now, before it's known that they're in the voting phase now, but afterwards they'll accept comments to that effect. When these new standards are adopted, there's some changes happen in the early days.
As the dropping of passive networks occurs, is there consideration given to keep a minimum density in the event of a sudden and total destruction of the satellite positioning systems?
For me, that is a rationale. We have a high-level network nationally. So we used to have we have a lot of passive control that has existed, and we're not keeping on top of it. We don't know what's happened to the monuments. We have a subset of them, which we call the National Densification Network, which has been visited by GPS since the 90s, and we are going to update those coordinates. We have the Canadian Base Network, which is also passive, but it's monumented, and we visit that periodically. So we have a level of passive control that we will be providing new coordinates for, very sparse. The provinces also have high precision networks, and my feeling is, and those are also passive control that has been visited by GPS, and my feeling is that the focus is really on maintaining those because they're higher accuracy. That doesn't mean you're going to have one close to where you're working necessarily. A lot of surveyors establish their own control, and so that's also going on. Yeah, Brian, I don't know if you have anything else to add on that.
Huge reliance on space-based positioning now, and I don't see that necessarily changing. And I don't see where there's funding models in place to really, well, there's no funding models in place to maintain a passive control network nationally. The country's just too large, and there's too many remote areas. But there is the densified networks in municipalities and some provincial densified networks which could be maintained. So I think, in built-up areas, there's the possibility of supporting a certain level of passive control through the densified networks, but there won't be anything at a national scale. And
there's many different GNSSs now, and so as we move towards multi-GNSS, that's a little bit of protection against that. There's discussion around low Earth orbit positioning systems, and that would be another kind of alternate that could support if one of the GNSSs goes out. Space weather is going to be an issue for both of those, but that's something that we've been dealing with for some time now.
How could you share experiences in support of a developing country like Madagascar if we plan to modernize our CSRS as well? I really appreciate your answer.
That's an interesting question. We have done that in the past. We've supported 2 countries in South America to implement our CSRS PPP system. That's not their network, their ground network. We had a project in Africa, in Dakar, to put up a new ACS. The challenge there is really getting the capacity to support that kind of work. There used to be some programs through Global Affairs that would do that. But I think we do have capacity in Canada to support that. Between, the universities have a fair bit of quite a lot of expertise in these kinds of systems still, and if we could find funding to support work in developing nations, there was likely to be interest in doing so. Our challenge has been about 10 years ago, the program we used to do that kind of work stopped, and there hasn't been a replacement.
Thanks. Hopefully, sure that answers the question. We're getting close to the bottom of the hour. I'd ask the panelists, do you see any particular questions still in the Q&A that you'd like to address? There's a couple of statements that aren't questions.
There was a question, transformation parameters for NAT83 CSRS are not available yet, but what type of transformation will it be? I presume a 7 parameter. Yes, it'll be a 7 parameter. Well, actually a 14 parameter, because it'll be the 7 parameter plus the the rates of change of the 7 parameters. So it'll be a 14 parameter transformation, very similar to the transformation now between NAT83 CSRS and ITRF.
There's a statement here. The Canadian Coast Guard is exploring alternatives to GNSS like eLORAN. That is a big, I think, concern for other organizations that need to do navigation and positioning. But as far as I understand, I don't think those alternatives are, at the geodetic quality. There is some alternative positioning services, but they're not going to get you centimeter level positioning. There's another statement. To date, ACS verticals fall short for mission critical heights.
So,
I wasn't sure exactly what it meant. Maybe they were saying that for, for very precise relative height differences, leveling is still the preferred method, which is correct. But I think, GNSS and the geoid model can play a huge role, because you can set local control, you can set your own local elevations, and then if you need to transfer that elevation locally, you can do it very precisely with geodetic leveling. So I think there's still a role for leveling within the modernized height system. Maybe that's what they're kind of pointing to.
Could be.
But
Um,
the CVD 2013 system is accessible anywhere in Canada at any time, very precisely using GNSS. But maybe relatively between two GNSS surveys, it's not quite as accurate relatively as it would be to, run a 50-meter geodetic leveling line. So, but they both play a role.
maybe I'll address this comment from Bernie again about work he's done with Madagascar to get a new grid shift file made from our partners at UNB. We've talked about grid shift files quite a lot on this project, and we've recently updated the software, which used to be able to only run on a 32-bit machine, but we've recompiled it and it's available now to run on a 64-bit machine. So we hand that out on request, and if they have a request to use it, they should let us know.
Great. There's a question here about, will there be a video of this presentation available in addition to the slide stack?
John asked me this before the presentation started. I think we can make that happen, but John and I will talk about that afterwards. Certainly the slides will be available for sure.
Great, thanks for that. Well, yeah, we're at the bottom of the hour. I want to thank NRCan, Jean-Sebastien, Brian, especially Catherine, for working with us on this. It's a very important update, and I'm really proud that you chose GoGeomatics to help share this with the community. Thank you all very much.
Thank you, John, for hosting.
Did you, before we close out, any final thoughts?
Well, yeah, in addition to thank you for hosting this, and I think that was super helpful, and it's good to broaden out to other audiences with the kind of reach that you guys have. Just to repeat again, this is meant to be a national introduction to this topic, to this community, and you may hear from us again to have more focused discussions in smaller groups in the coming year, because we really want to understand what the challenges are and how we can help facilitate getting over them. Not that this is going to happen overnight, but over the coming years, what kind of support we can provide from a geodetic perspective that would help unify reference frame usage across the country.
And for any news of upcoming information that's going to be shared, I encourage everybody to sign up for our free weekly newsletter.